Hey everyone, so this week we're going to go through anti-differentiation again. Of course, something new, this time on your trigonometric identities with two functions. So, the simple question would just be anti-derived sine square x or anti-derived sine cube x or cos cube x by itself. Hopefully those should be fine. If you have any questions, just leave a comment and maybe I'll go into those questions if you need help with. Right, but we want to cover the harder question. In this case, anti-derived sine square x times by cos cube x dx. How do you go about this? In this case, when you've got two functions and one of them's odd, one of them's even, if you've got two evens, check out my other video where I do sine square x, cos square x. If it's just odd and even, then the odd power takes priority. Right, so in this case, you work with the odd power first. Leave sine square by itself. And when you're working with odd power, you want to turn that odd power, so it's usually cube. You want to bring that into an even, and you want to bring it so that you only have cos x by itself. So to the power of 1, you want to have just that by itself, and your cos square x. So if it's cos 5x, you would have cos to the power of 4x times by cos to the power of 1x. So you want the 1, that's the special part. Okay, so in this case, we have cos square x times by cos x, because if you multiply that, you still get your cos cube x. Right, afterwards, we use our identity rule. So sine square is still sine square, but we use our identity rule on that cos square. 1 minus sine square, so that's our identity rule. That should equal to cos square x. Then you leave the cos x by itself. We're going to use that as a fodder, and you will see. So sine square times 1 is sine square x. Sine square times sine square is minus sine to the power of 4x. Inside a big bracket, multiply by cos x. Okay, that lonely cos x, don't worry, we're going to eliminate it. This is like a sad story, I guess. Oh, you're pretty much trying to get rid of the loner kind of thing. Okay, enough about that. Let's go back into our equation. Sine square x minus sine 4x times cos x. What do we do here? So, as we've learned before, the substitution method. Let's u equals to sine x, right? I mean, it looks complicated, just let u equals that. In this case, du dx would be cos x, and therefore the x would be du on cos of x. So just bring x up top and then swap dx and cos x together. Then your integrand becomes u squared minus u to the power 4 because u is sine. So in this case, just sub them in. And of course, it's multiplied by cos x. Conveniently, dx, we sub it back in as well, du over cos x. And what do you see here? That's why we use the substitution method. You cancel out the cos x. So cos is literally your fodder. It's just there to be cancelled out so that you can use the substitution method. Afterwards, derive normally, u squared, derive that, we get u to the power of 3, bring 3 down, subtract by u, 4 plus 1 is 5, bring 5 down, plus c, and you substitute what u originally is, which in this case is sine x, and over here as well, sine 5x plus c, and that is your final answer. That's it. So I'll summarize it here. If you have an odd power and an even power together in one function, what you want to do is you work on the odd power first. So bring the odd power down into to the power of 1, so cos x or sine x, and then the other one is just the remainder. So if it's cos to the power of 3, that becomes a square. If it's to the power of 9, that becomes an 8, and that's a 1. Should always be a 1 there. Afterwards, expand it so that you have cos by itself, and then you get the other function. So this can be sine, that can be cos, really. Just want to get rid of that. So substitution, dx equals du over cos x, then you get rid of it, anti-derived normally because you get a polynomial, and that's your answer. So that's pretty much it for this video. Pretty quick video, but if you have any questions, just leave a comment. But hopefully you took something new from this tutorial video, and thanks for watching. I'll see you next class.